We analyzed the total suspended solids and total phosphorus levels over the years in the lower Green Bay and lower Fox rivers that are areas of concern. The red areas on this map illustrate waters impaired by phosphorus or sediment. This graph shows the annual summer median total phosphorus concentrations from 1993 through 2008 for the lower Fox River. The red line shows the water quality target. This graph, similar to the last one, shows the total suspended solid concentrations. Aaron Wilcox from New Water can help explain a little bit about total phosphorus and total suspended solid levels currently.
Right now we're actually seeing quite a large amount of suspended solids in our rivers because we've had a pretty good melt from our winter snow this past winter, and then we've had a lot of different rain events. Just between a big rain event in December and then we kind of had a couple calm months while we got some snow, but we've had several rain events that have kept our water bodies really high right now and a lot of runoff coming in, so it'll be interesting to see what happens this summer.
Total phosphorus and total suspended solids tend to move together, so when one increases you usually see an increase in the other, and vice versa. Often in our environment, phosphorus is attached to soil particles. When these particles get washed off the landscape and end up in the water, we see a resulting increase in both our TP and TSS levels. Total suspended solids can include a wide variety of material, such as soil, biological solids, decaying organic matter, and particles discharged in water waste.
We haven't gotten out and tested yet this spring, but last year in 2015, we actually didn't see as much loading as we usually do in the early spring, and so we actually saw pretty good water quality parameters this past year. Our total phosphorus and total suspended solids were lower last year than many of the previous years.
A significant amount of phosphorus is discharged into the lower Fox River from municipal and industrial discharges, as well as from runoff, croplands, barnyards, construction sites, parking lots, residential yards, streets, and other sources. Many of these sources also contribute significant amounts of sediment to the river and bay as well. In general, we see larger concentrations of TP and TSS in the rivers. As water moves downstreams and meets the bay, the particles can settle out in the water. So farther out in the bay, we should expect to see lower concentrations of TP and TSS. TP and TSS both contribute to the dead zones or low oxygen zones that we have in lower Green Bay. The phosphorus can spur algae growth. These blooms will start to die and sink to the bottom of Green Bay along with the suspended solids. These materials are then eaten by microbes that live on the bottom. These organisms consume oxygen and respire CO2. So they devour the organic material. They are drawing down the oxygen levels in the bottom of the water. If we reduce the amount of TP and TSS getting into our rivers and lakes, we can reduce the size and frequency of these low oxygen regions. Some of the main restoration goals for the lower Fox River and Green Bay are to reduce the excess algae growth and increase water clarity, increase growth of beneficial submerged aquatic vegetation, and restore degraded habitats. These goals can be achieved in part with decreasing total phosphorus and total suspended solid levels.
So one of the big things is trying to keep our wastewater treatment plant operating as good as it possibly can be. So optimizing our processes here at the treatment plant, so making sure that our effluent that we then contribute to the rivers and the bay is of the highest quality. The second component to that is our work in the watershed. So we're trying to improve water quality in the rivers and bay by working on reducing what's running off of the area that we all inhabit. So our agricultural areas, our other rural areas, and all of our industry and urban areas.
We need to raise awareness of this issue so we and the species living around us can live in a healthy environment. We would like to thank Aaron Wilcox from the New Water for the interview and data.